Here's that same pattern of numbers that we worked with in yesterday's video, and we're going to continue this down now into the negative exponents. So I'm going to keep this base of 8. I'm going to drop our exponent by 1. And this pattern of dividing by that base, dividing by 8, will continue. So 8 to the negative 1 power is going to be my previous answer of 1 divided by 8, which is a fraction, 1/8. Or if I take my calculator and do 8 to the negative 1 power, there it is as a decimal. And when I math frac that, there's my 1/8. So when I go down to 8 to the negative 2 power, this means I'm taking my answer of 1/8 and dividing it by 8. But if I'm dividing by fractions, I do not divide. I actually multiply by the reciprocal. So I'll actually be doing 1/8 times 1/8, which makes 1/64. Or on my calculator, if I want to check that, 8 to the negative 2 power, there it is as a decimal. And when I math frac it, there's the 1/64 as a fraction. Continuing on, dropping by another 1 in the exponent, 8 to the negative 3rd means I'm going to be doing 1/64 divided by 8, or times by 1/8. And 1/64 times 1/8 is 1/512. And at this point, hopefully you're saying, man, these denominators are looking a little familiar. And you are right, because notice 8 to the negative 3, I have a 512 in the denominator. That's how much 8 to the positive 3 was 512. 8 squared is 64. 8 to the negative squared is 1/64. 8 to the first is 8. 8 to the negative first is 1/8. So now when I go down to calculate 8 to the negative 4th, I know my answer is going to be 1 over however much 8 to the 4th was, 4,096. And then if I wanted to keep going, for example, 8 to the negative 5th would be 1 over however much 8 to the 5th is. 8 to the negative any exponent is going to be 1 over 8 to the any exponent. And this is our next law of exponents, that anytime I have a base with a negative exponent, that is the equivalent to the reciprocal, or 1 over that base to the exponent. Once you have this written down on your index card, flip your card over to the other side, pause the video and write down these 6 problems. And now let's go through and simplify these 6 problems. 4 to the negative 3rd, I see a negative exponent, so I'm doing the reciprocal of my base with its exponent. 1 over 4 to the 3rd is 1 over 4 times 4 times 4, which is equivalent to 1/64. Next one, x to the negative 5th. I'm going to do 1 over my base to the positive exponent of 5. Next problem, 4x to the negative 1. Now I have a coefficient in the front. That's going to stay there. And my base that's with the negative 1, I'm going to do 1 over that base to the positive 1. And then if I actually want to multiply these two fractions together, it'll be 4 over 1 times 1 over x, which is equivalent to 4 over x. Next problem down here, same numbers as the previous one, but now we have parentheses that's giving 4x as the entire base with the negative 1 exponent. So now I'm going to do 1 over 4x as my base to the positive 1 power, which is equivalent to 1 over 4x. Next one, now I have a negative exponent in the denominator, so mathematically that means I'm going to have 1 over, and then this x to the negative fourth is going to be 1 over x to the fourth. This fraction is looking pretty nasty here, a fraction inside of a fraction, so let's divide out here. 1 divided by 1 over x to the fourth is the same thing as 1 times the reciprocal, x to the fourth, and that gives me x to the fourth. And the last problem, when I do 9 divided by 3, that gives us a 3, and I still have that x to the negative 2 to deal with in the denominator. So that's going to make it a 3 in the top and a 1 over x to the positive 2 in the bottom. And then dividing by the reciprocal will actually change that into 3 times x squared, otherwise known as 3x squared.